This is Miss Sebastian, and we're going to look at Unit 3 using graphs to analyze data, the unit test. So this is covering all of Unit 3. So what are the mean, median, mode, and range of the data set given that deal with the altitude of lakes in feet? So the first thing we're going to do is we're going to put these in order least to greatest. So I know negative 53 is the least, then negative 38, negative 32, negative 25, negative 22, negative 21, and then our two negative 8s. Okay, so now that we have that from least to greatest, I can count my numbers. I have 1, 2, 3, 4, 5, 6, 7, 8. So halfway is right here. So that means we're going to find the mean of 25 and negative 22. So we're going to add those together and then divide by 2. So negative 25 plus negative 22 is negative 40. So given this data, what is the outlier in the data? Then the mean with the outlier and the mean without the outlier. So the first thing we're going to do is look and see which one does not fit in our data. We've got 20, 17, 13, 32, 17, 20, 20, and 25. So I would say the outlier is this 32. It is the highest, and it is more than 7 away. So I'm going to say 32 is the outlier. And what is the mean with the outlier? So we're going to add them all up. So we're going to say 20 plus 17 plus 13 plus 32 plus 17 plus 20 plus 20 plus 25. Okay, which frequency table represents the set of data below? We're actually going to make our frequency table, and it's related to each student's favorite pets. So a frequency table, all it is a table that has all of the options listed. We've got cat, dog, bird, fish, and none. Those are just the ones I see. If we run across another one, then we can always add it. So I'm going to go down and I'm going to say I see cat 1, 2, 3, 4, 5, 6, 7, 8. Now in a frequency table, you always use tally marks if they do not specify. Okay, then I'm going to dog. I've got 1, 2, 3, 4, 5, 6, 7, 8 dogs. Then I'm going to go to birds. So I've got 1, 2, 3, 4. And then fish, we've got 1, 2, 3. And then none, would be just 1. So there is our frequency table. That's what it's going to look like. It doesn't have to be all different colors. That just let us separate those to make sure that The data below represents the ages of the first 10 people in line at the movie theater. So we're going to make a line plot with this data. And I've already got our number line down here. So all we're going to do is look at the first number. It's 23. So I'm going to put an X on the graph, or right above the graph where I see 23. The next number is 29. So I'm going to put an X on the graph at 29. The next number is 28. Then 22, and I've actually got two 22s, so I'm going to go up with that one. And then 24, 28, 24, and 30. That is what a line plot looks like with this data. Make a stem and leaf plot that represents the data set below. So the first thing I'm going to do is I'm going to find my lowest number, and it looks like it's 56. So I'm going to start my stem and leaf plot with a 5 in the tens place. Then I've got a 6 in the ones place. That's going to be my leaf. I've already used that one. Then I see a 57, so I'm going to put a 7 there. The 5 is in the tens place. The 7's in the ones place. Then I see a 58. So 5 is in the tens place, 8 is in the ones place. Looks like I'm out of all the 50s now, but I've got some 60s. I've got 61 and 66. So I'm going to put a 6 down for the tens place, a 1 down for the ones place, so it'd be 61, and then 66. You've got the 6 in the tens place, you need the 6 in the ones place. So I've used both of those. Now we can go to 7s. I've got 70, 7 in the tens place, 0 in the ones place, and then 76, 7 in the tens place, 6 in the ones place. Then I've got 80s. I don't see any 80s, but you can still put the 8 there just as a placeholder. And then we've got 9s. We've got 99 and we've got 90. So we're going to put 0 there for 90. And 99 is a 9 in the tens place, a 9 in the ones place. And last we have our hundreds. We've got 103 and 118. So we're going to start with 10 in the tens place. That would be the same as 10 times 10, which is 100. And that leaf is just the 3, so it'd be 103. Then we've got 118. It's not a 10 in the tens place, it's an 11. Okay. And an 8 in the ones place. This would be your tens place, but we have to put both because it is the stem. And the 8 in the ones place. What is the median number of hours for each brand? So on brand A, I'm going to count how many numbers I have. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So half of 13 is 6.5. But if I do 1, 2, 3, 4, 5, 6, put a line, and count backwards from the end, 1, 2, 3, 4, 5, 6, I have 4 in the middle, and then there's 6 on each side. So the median for brand A is a stem of 1, a leaf of 4. So that's 14. So I'm going to do the same with brand B. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Oh, we got the same line there, which means we're going to have to find the average of these two. So 7 plus 9 divided by 2. 7 plus 9 is 16. Divided by 2 is 8. So the average, or the median of brand B is 8, but we do still have that stem. So that would be 18. Okay, let's make a box and whisker plot for this set of data. So I want to look and I want to find the minimum number. The minimum means the absolute lowest number. That'll be 1. The absolute highest number is 24. Now I'm going to go ahead and put these in order because it's easier to look at the data that way, especially when you're making these box and whisker plots. 10, 11, 12. $18, 19, 21, 22, 23, 24. Okay, so I've got those put in order from least to greatest. And so now I'm going to find the median. That's the same thing as quartile 2. That's the median. So I'm going to say, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So I'm going to count from both sides. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And that tells me 12 is in the middle. So now I've got to divide both sides and find the median of each side. So the median of this side would be quartile 1. The median of this side would be quartile 3. So I've got 1, 2, 3, 4, 5, 6 numbers. So 3, it would be in the middle of here. So I've got to find the average of these. So 7 plus 9 is 16. Divided by 2 is 8. I do the same thing over here. I've got to find the middle of 21 and 22. So 21 plus 22 divided by 2, that'd be 43. And half of that is 21 and a half. So what that does is it tells me, okay, I'm going to put a dot at 1 for this minimum. I'm going to put a dot at 24 for the maximum. Okay, now I'm going to put a line up and down on 12 for the median, a line up and down on 8, and a line up and down on 21 and a half. Now I'm going to make a box. Connect there, connect there, there, and there, and then these are the whiskers. Your line can be a lot straighter than mine. I'm just trying to get it to show up over the graph there, but that is what your box and whisker plot looks like. A penguin's incubation time is 28 days. How does the penguin's incubation time compare? So on this one, we look at the quarter 1, quarter 2, and quarter 3. Those are those quartiles that we found on the last one. They actually account for percentages. So if we look at the penguin's incubation time of 28 days, that's here. That is 70, it is above 75% of the rest of the incubation times. So the penguins is higher than 75% of all those different fowls, I guess, birds, incubation time. Draw a scatter plot that matches the data. So what we're going to do is we're going to label our x-axis by 1s. Okay. And then we need to go up to 65. So I'm going to go by 5s, going up my y-axis. And you can choose however you want to do this. But that's just the labels that I chose. So now we're going to do our first point. So it's at 1 with 2 birds. So day 1 they had 2 birds. Day 2 they had 10 birds. Day 3 they had 5 birds. Day 4 they had 16 birds. Day 5 they had 6 birds. 6 birds. Day 6 they had 15 birds. Day 7 they had 20 birds. Whoops, sorry about that. Missed it just a tad. Okay, day 8 they had 12 birds. Day 9 they had 28. Day 10 they had 30. Day 11 was 28. Day 12 was 35. Day 13 was 37. Day 14 was 32. Day 15 was 45. Day 16 was 39. 17, 56. 18 was 52. 19 was 60. And 20 was 65. So as you notice, all of these points are going up and to the right. So if they ask you to describe the trend, it would be positive. What type of trend does the scatter plot below show? Notice this one is going down and to the right. The last one we looked at was going up and to the right. This one's going down and to the right. So it is negative. That has a negative slope. So it is a negative trend. Okay, what kind of real-world situation might the scatter plot represent? Maybe the following table gives the math scores of 10 friends. What is the score of the outlier, the one that doesn't fit? You've got 46, 29, 35, 93, 37, 38, 45. 44, 46, and 31. The one that does not fit, the one that is too big for its britches, is Dave. Okay, Arthur made the scatter plot below of the temperature outside his house over the course of 9 days at the beginning of winter. If this continues, what will most likely be the temperature on day 11? So I look, and if I try to draw a line through this data, now this is not the best line, but it gives me sort of an idea. I go over to where 11 is on my days, and I go up until it hits my line, and it hits right there. So I look over, and that is at 15. So the temperature would most likely be 15 degrees on day 11. If 150 people were surveyed, how many more people like squash than zucchini? So if 150 were surveyed, and purple is squash, that's 25%. So I'm going to multiply 150 by 25, and that's 37.5. Doesn't really make sense, but that's okay. Then we're going to see zucchini. And that was 15%. So we're going to multiply 150 times 15. And that is a survey about the student government program at a school finds the following results. 100 students like the program. 20 students think the program is unnecessary. And 60 students plan on running for student government next year. If a circle graph were made from the data, what is the measure of the central angle for the group that plans on running for student government? So first we need to know how many total students there are. So we're going to add 100 plus 20 plus 60, and that does give us 180 students, and 60 of those plan on running for student government, divided by the 180 total. That's going to give us a fraction. We know that there are 360 degrees in a circle, and we want to know what percentage of those are the, what degrees would represent those 60 that plan on running. So we're going to cross multiply, or we could look and see what multiplies by 180 to get 360. I know that if I multiply 180 by 2, I get 360. So because of that, I can also multiply the top by 2. 60 by 2 gives me 120 degrees. We could also do it by cross multiplying. 60 times 360 equals 180 times x. 60 times 360 gives me 21,600. Then we're going to divide by 180. Based on the two-way frequency table, how many people chose basketball? So I'm going to look at basketball, and I'm going to come down here. I see 22 males, 16 females, and 38 total. So how many people chose basketball? 38 did, and they got that by 22 plus 16 gave me 38. What percentage of males chose baseball? So I'm only going to look at the male column. So this data doesn't matter. So I need to know how many total males there are. So 40, 22, and 15. I need to add to know how many total. So I've got 77 males. How many chose baseball? Well, baseball was 15. So I need to do 15 divided by 77. And I get, oops, there we go, 0.195. Now if I want to change that to a percentage, I move the decimal to the right 2 spots. So I get 19.5. Okay, intervals for the average number of movies. So if I was going to draw a histogram, I would split these into small intervals. So I want to look and see what my best course would be here. And I could say, okay, I want to do 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. I could do that. If I wanted more intervals, I could say 0.5 to 1, 1 to 1.5, 1.5 to 2, 2 to 2.5, 2.5 to 3, 3 to 3.5, 3.5 to 4, and 4 to 4.5. It all depends on the amount of room you have, as well as what represents the data. I would probably go with this first one. Do 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Okay, how many students like exactly one sport listed? So if I look here in this area, this is where my circles overlapped. Those students like two sports. They like golf and boxing. This 13 here, those like boxing and kayaking. 2 like golf and kayaking. And then the 3 in the middle like all 3 sports. That's where they all overlap. So that's not our answer. And then down here, this 8 in the bottom left corner, they don't like any of them. So the ones that we're left with like just one. The 19 like just golf. The 18 like just boxing. And the 12 like just kayaking. So we're going to add together those numbers to see exactly one sport, the students that like that. There is a total. Okay, make a stem and leaf plot that shows the following data. So I'm going to look and see my smallest number, and it looks like that's 41. So I'm going to start with a stem of 4, and I'm going to put a 1 for the leaf, because 4 in the tens place, 1 in the ones place. Then I've got 42, so 4 in the stem, 2 in the leaf, and I don't see any more 4s, but I do see some 5s. So I'm going to put the stem as 5, then I see 53, 54, another 54, and a 58. Then I'm going to the 60s. I see 67, 65, 65, 69. So 65, 65, 67, 69. Notice that most of these are least to greatest when listing those leaves. And you can put blanks here until you get down to the one you need. You don't have to, 7, 8, and 9, but I do just because I make sure that I covered everything. And then my key, 6 in the tens place, 5 in the ones place, is 65.